Hi student, in last lecture we start new point, derivatives of logarithmic functions, and in that lecture we see exercise number 1.3, question number 1 to question number 3, question 1 to 3. Now we start next question, that is question number 4. What is question 4 here? Y is equal to x square plus 2x plus 2 raised to 3 by 2 and upon whole thing divided by root x plus 3 whole bracket cube into cos x whole raised to x. So write differentiate with respect to x. So first we don't find the derivative of this function directly. So here first we apply logarithm on both sides. Taking logarithm on both sides. On both sides. Therefore we get log 1 is equal to log of x square plus 2x plus 2 raised to 3 by 2 divided by root x plus 3 cube into cos x raised to x. Now look at this is in the form of log of m upon n. Log of m upon n, that is log m minus log n, which is called as a quotient law of logarithm. In last lecture we see these three laws: quotient law, product law and exponent laws of logarithm. Now log 1 is equal to, now we apply this log of x square plus 2x plus 2 raised to 3 by 2 minus log of root x plus 3 bracket cube into cos x raised to x is equal to log of x square plus 2x plus 2 raised to 3 by 2, right, as it is. Now here look at log of m into n, again there is product. So in logarithmic form we take addition minus log of root x plus 3 cube log m into n, that is log m plus log n, but here minus sign, so log of cos x raised to x by using product law of logarithm. Log m into n is equal to log m plus log n. Now using exponent law of logarithm, that is x square plus 2 raised to 3 by 2, 3 by 2 into log of x square plus 2x plus 2 minus here 3 into log of root x plus 3 minus x into log of cos x by using exponent law. Now we differentiate with respect to x. Differentiate with respect to x. Now what is the derivative of log y? 1 upon y. Derivative of log y is 1 upon y into derivative of 1 dy upon dx is equal to this 3 by 2 is constant, so write as it is. Now this is in the form of log f of x. What is the derivative of log f of x? 1 upon f of x. X square plus 2x plus 2 into multiply the derivative of function. What is function here? X square plus 2x plus 2. What is derivative of this? Derivative of x square is 2x and derivative of 2x is 2. Minus this 3 is constant. Now again derivative of this log 1 upon root x plus 3. Log of root x plus 3 into multiply the derivative of this root x plus 3. Now what is derivative of root x? 1 upon 2 root x and derivative of 3 is 0. Minus here we have to use product rule because there is two functions u into v. So x into derivative of log of cos is 1 upon cos x into derivative of cos is minus sin x. Derivative of cos is minus sin x plus, now write this log of cos as it is, into derivative of x is 1. Therefore 1 upon 1 into dy upon dx is equal to 3 by 2 into, now here 2x plus 2, so we take 2 common from this, so here we write 3 into 2 into x plus 1 divided by x square plus 2x plus 2 minus 3 upon 2 root x. So write here minus 3 by 2 root x into root x plus 3. 2 root x upon root x plus 3. Minus, look at here. Here minus minus it become plus. And sine upon cos, that is tan. That is plus x into tan x. X into tan x. And plus minus, that is minus log of cos x. Minus log of cos x. But we have to find dy upon dx. So this 1 we write here. That 3 into 2, 6 into x plus 1. Now this 2 will get cancelled here. 2 will cancel. Right? 3 into x plus 1 upon x square plus 2x plus 2 minus 3 upon 2 root x into root x plus 3 plus x tan x minus log of cos x. Now put the value of 1 and write again answer. dy upon dx. Use here value of 1. X square plus 2x plus 2 raised to 3 by 2 divided by root x plus 3 cube into cos x raised to x, and write this answer again here as it is. So this is the answer of question number 4. Now see question number 5. In question number 1. What is question 5 here? y is equal to x raised to 5 into tan cube of 4x divided by sine square of 3x. Sine square of 3x. Again, taking log on both sides. Taking logarithm on both sides. Therefore, we get log y is equal to log of x raised to 5 into tan cube of 4x divided by sine square 3x. Now again, which is in the form of log of m upon n. Log y is equal to log of x raised to 5 into tan cube 4x minus log of sine square 3x. Which law? Quotient law. Therefore, log y is equal to, again here product of two terms. So here we take addition of these two, log of x raised to 5 plus log of tan cube 4x minus log of sine square 3x. Now look at this tan cube and sine square. If there is tan square theta, in last lecture we see tan square theta can be written as tan theta square. So here we write this tan cube in form of tan 4x bracket cube, and this sine square as a sine 3x square. So here we use now exponent law, 5 log x plus 3 into log of tan 4x minus 2 into log of sine 3x. Here we use exponent law and here we use product law. Now we differentiate with respect to x. Take differentiation. Differentiate with respect to x. Now what is derivative of log 1? 1 upon y into dy upon dx. This 5 is constant. Derivative of log x is 1 upon x. 3 into derivative of tan log is 1 upon tan 4x into, take derivative of tan 4x, which is x square 4x, and derivative of 4x is 4, minus 2 into log of sine 3x is 1 upon sine 3x into derivative of sine 3x is cos 3x and derivative of 3x is 3. This is a composite functions, that is functions of function, is equal to 5 upon x plus here 3 into 4 is 12 sec square 4x upon tan 4x minus 2 into 3 6 cos 3 upon sin 3, that is cot 3x, which is a value of 1 upon y dy upon dx. Now we simplify this sec square and tan 4x. Sec square means what? 1 upon cos 4x and tan means sin upon cos. Therefore, dy upon dx is equal to y into 5 upon x plus this 12 write as it is. This sec square we write as. Now this tan, look at this tan. In denominator we write sin 4x upon cos 4x. So this cos 4x will get in numerator of this. So cos 4x upon tan 4x. 1 upon tan means it is cot. 1 upon tan means cot, and cot is cos upon tan, and sec square 4x can be written as 1 upon cos square 4x minus 6 cot 3 as it is equal to y into 5 upon x plus 12 into, now look at here, cos 4x and 1 cos 4x will get cancelled. Here no tan, there is sin 4x. Sin 4x. Now look at here, in denominator there is sin 4x into cos 4x, and all of you know the formula of sin 2 theta is equal to 2 sin theta into cos theta. Sin 2 theta is 2 sin theta into cos theta. So if we take here 2, then 2 sin theta into cos theta, we write sin of 2 into 4x. When we write this, if there is 2, so we adjust 2, then we multiply and divide it by 2. Here we multiply and divide by 2, and the sin 4x and cos 4x as it is. Minus 6 cot 3x. Now look at, this is 2 sin theta into cos theta, which is equal to sin 2 into theta. But here value of theta is 4x. So our angle becomes, now use value of y, x raised to 5 into tan cube 4x divided by sin square of 3x. 5 upon x plus 12 into 2, 24, and the 2 sin 4 into cos, that is sin 2 into 4, since it is sin 8x minus 6 cot 3x. Again this 1 upon sin 8x we write as cosec 8x. Tan cube 4x upon sin square 3x in bracket 5 upon x plus 25 into 1 upon sin is cosec 8x minus 6 cot 3x dy upon dx. Example number 5. Now see question number 6 here. What is question 6? X raised to tan inverse x. The examples which are of the form function raised to function is solved by using logarithm. So here, taking logarithm on both sides, therefore we write log y is equal to log of x raised to tan inverse x, which is equal to tan inverse x into log x by exponent law of logarithm. Exponent law of logarithm. Now differentiate with respect to x. That is derivative of log y 1 upon y, derivative of y dy upon dx. dx. Here we use product rule for the derivative. First function into derivative of second. Derivative of log is 1 upon x plus log into derivative of first. That is 1 upon 1 plus. We know that derivative of tan inverse is 1 upon 1 plus x square. Don't forget the formula of inverse trigonometric functions. So here tan inverse x upon x plus log x upon 1 plus x square. d1 upon dx is equal to 1. Therefore, write the value of 1. What is y given? X raised to tan inverse x into tan inverse x upon x plus log x upon 1 plus x square. Question number 6. Question 7. Notice question 7 here, that is sin x raised to x. Sin x whole bracket raised to x, again which is in the form of f of x raised to g of x. Taking logarithm on both sides. So log y is equal to log of sin x raised to x is equal to x into log of sin x. Differentiate with respect to x. 1 upon 1 d1 upon dx. Take product rule. X into derivative of this function, that is 1 upon sin into derivative of sin is cos plus log of sin as it is into derivative of x is 1. Therefore d1 upon dx is equal to 1 into x into cos upon sin cot x plus log of sin x. Now write the value of 1. Sin x raised to x into y cot x plus log of sin x. Question number 7. Now what is question 8? That is sin x raised to x. Sin x raised to 8x. Now this is not in the form of f of x raised to g of x. Which is not in the form of f of x raised to g of x. This is in the form of f of g of x. This is a composite function. So how to find derivative of the composite function? That is, take first derivative. This is a sin f of x. Sin f of x. And derivative of sin f of x is what? Cos f of x into derivative of function. So here don't apply logarithm. These are not same. These are different functions. Sin x raised to x and this is a sin x raised to x. This is of the form function raised to function, but this is of the form function of function. These two things are different. This is function raised to function and this is called as a composite function. So don't apply the log here. So here we take direct derivative. Differentiate with respect to x. Or we solve this example also by using composite function because, so take here, let us consider where u is equal to x raised to x. Here I take x raised to x is equal to u. Then the y becomes sin u. Y becomes sin u. Now here y is a function of u, but u is a function of x. And in the derivative of composite function, we see how to find the derivative of composite function. dy upon dx is equal to what? dy upon du into du upon dx. So by using composite function, we find the derivative of this function. So differentiate with respect to u because y is a function of u. Therefore, dy upon du is equal to cos u. And what is value of u? That is cos of x raised to x. Say first. Now find derivative of u. Like u is equal to x raised to x. Differentiate with respect to x. But here we can't find the derivative of this because this is of the form function raised to function. So take logarithm on both sides. Taking logarithm on both sides. Therefore, log u is equal to log of x raised to x, and this can be written as x into log x. Now differentiate with respect to x. Differentiate with respect to x. Now what is derivative of log u? That is 1 upon u. And derivative of u with respect to x? Du upon dx. In RHS we use product rule. X into derivative of log x, 1 upon x, plus log x into derivative of x is 1. Du upon dx is equal to u into x upon x get cancelled, 1 plus log x. Right value of u. One plus log x. Therefore, by using composite function theorem or by chain rule, what is value of d1 upon dx? d1 upon du into du upon dx. From 1 and 2, cos x raised to x into du upon dx is x raised to x into from 1 and 2. Hence, this is the answer. Look at these two are different forms. So here we can't write sin x raised to x is not equal to sin x raised to x. These are different functions. So when this type of function, we will take composite function theorem. Now see the next question, that is question number 2 in exercise number 1.3. Question 2. Differentiate following functions with respect to x. Differentiate with respect to x. So first example is there, x raised to e plus x raised to x plus e raised to x plus e raised to e. Now look at here don't apply logarithm because there is no rule for this. That is log of m plus n is not equal to log m plus log n, which is incorrect. So don't apply log on this type of examples. So look at here, first function is there, x raised to e, that is in the form of x raised to a. We find the derivative of this type of function or a power function, x raised to n. This is of the same form. Now this is a function raised to function. Here we find the derivative of this. Derivative of x raised to x is x raised to x into 1 plus log x. Here we use this directly, but if in exam you have to ask this type of question, then you have to solve the derivative of x raised to x. Here we find e raised to derivative of e raised to x and derivative of e raised to e is constant. So take differentiate with respect to x. d1 upon dx is equal to, what is derivative of x raised to e? What is derivative of x raised to n? n into x raised to n minus 1. So here in power is e. So we have e x raised to e minus 1 plus. Here we find the derivative by taking logarithm. But I am using directly. But in exam, if you have to ask the question of this type, then you should try to find the derivative of this x raised to x and then write this. X raised to x into 1 plus log x plus derivative of e raised to x is e raised to x and derivative of e raised to e, constant raised to constant, since the derivative is 0. This is a derivative. Now, second question, y is equal to x raised to x plus e raised to x. Let u is equal to x raised to x and v is equal to e raised to x. Because here there is no rule for logarithm for addition log of m plus n not equal to log m plus log n. So here we write y is equal to u plus v. Therefore value of dy upon dx is equal to du upon dx plus dv upon dx. So first you should try to solve du by dx and dv upon dx. So let's take y is equal to, say, u is equal to x raised to x. X raised to x, taking log on both sides. On that type of function, we can't use direct logarithm. Log u is equal to log of x raised to x. So this can be written as x raised to x into log x. Differentiate with respect to x. 1 upon u du upon dx. Use product rule, x raised to x, derivative of log x 1 upon x plus log x into derivative of x raised to x. Now again I am writing here the derivative of x raised to x. But in exam, if you have to ask the question of this type, then you find the derivative of this first and then write du upon dx is equal to u into x raised to x upon x plus log x into, what is derivative of x raised to x? In previous example we find this, that is x raised to x into 1 plus log x. Now write value of u, that is x raised to x. From this we take x raised to x common. Then here we get one upon x plus log x into 1 plus log x. Also we take log x common. Then this turns into 1 upon x into log x, because if we multiply again by log x, then log x will get cancel and there is only 1 upon x plus 1 plus log x. Say this as a equation 1, this as a equation 2. Now here we get du upon dx. Next we find dv upon dx. So what is v? E raised to x. Here don't apply logarithm on both sides, because this is of the form e raised to f of x. This is of the form e raised to f of x, and we find the derivative of e raised to f of x by composite function e raised to f into f dash. So dv upon dx. What is derivative of e raised to f of x? That is e raised to, write the function as it is and into multiply the derivative of function. So e raised to x into take the derivative of x raised to x. And we know the derivative of x raised to x. What is derivative of x raised to x? In earlier example, we find this. And if you don't find the derivative of this, then first find the derivative. So write derivative of this x raised to x into 1 plus log x. Equation number 3. Now from 1, 2 and 3 we write dy upon dx. From 1, 2 and 3 dy upon dx is equal to first du upon dx. Right, value of du upon dx x raised to x into log x in bracket 1 upon x into log x plus 1 plus log x plus dv upon dx. Right, value of dv upon dx e raised to x raised to x into 1 plus log x. This is our dy upon dx of example number 2. The remaining examples we solve in next lecture.